First of all, thank you for coming this meetup. We will start with the topic one about Kubernetes. I think Curtis will be talking about what are the gaps we can actually remediate when Kubernetes is a kind of open source by default. And the second from Simon, we're talking about the Istio mesh or the application networking. And after that, we'll be having some lucky draws. We have some giveaway for you guys. And the next is for the full be available after 7 p.m. You have it and you have a good networking, peer networking, chit chat. You can talk to our speakers as well. And we'll let you know our next event next month. So I quickly introduce Curtis to. So I'll
let me connect to Zoom.
Allow me to introduce this area, like very high technical roles he's playing in Sysdig. Recently, actually, I did some certifications from the Dragon Hunter. He knows a lot of stuff from the Kubernetes securities, Kubernetes monitoring, and then applications networking as well, and CI/CD pipeline, and so on. So that is over to you. Okay. And let's start with this topic. Thank you so much. Yeah, it's just running this one. Okay, no, should be. How is that? Okay. Good.
Hello. All right. Can everybody hear me? That's good. Yeah. Okay. Might try to balance this over here somewhere, maybe. Okay. So who here is using Kubernetes like on a day-to-day basis? Who's using Kubernetes? Anybody? Pretty much everybody in the room? Yeah, quite a bit. Okay, that's good. So what I'd like to talk to you about is why Kubernetes is insecure by default, and then like 3 steps you could take to make it less secure by default. And so like I'm guessing like how much is everybody fairly experienced with Kubernetes? Like do you have or is it you're new to it? Who's really experienced with Kubernetes? No, yeah, a couple, yeah. So the point of what I kind of want to talk about today is not really to like solve like a million problems. It's to solve, if you deploy Kubernetes, what are a couple things that you could do to just make it secure, like right from the get-go, right? Like what are like 2 or 3 things that should be there by default, right? Like I'm not trying to solve, every bank's problems with Kubernetes or, fix every vulnerability in the images. I just want to give you like 2 or 3 ideas that would work in any situation, right? And there would be some opinions, and it's okay to have opinions. Like if some of the things that I'm telling you, you're like, that doesn't make any sense. I don't want people to be able to egress out to the internet. That's not security. Like, feel free to disagree with me, right? Like the point of this is like, here's a couple of ideas that you could do, right? But maybe you wouldn't. Or you could kind of call this talk insecure by default, building on ruins of the past, right? So I work at Sysdig. It's mostly a security company. It's also a monitoring company. We focus really on the runtime security piece. I might mention that a little bit more. But I tend to really focus on like the social, or try to focus on the social technical aspects of what people do with technology, right? And by that, I mean, it's like, there's a lot of people in the room using Kubernetes, but is it like fun to use? Is it easy to use? Is it like enjoyable to use? Do you say it's overly complex? Like, why do people say that it's overly complex? Is it because it actually is complex, or because it's just hard to use, right? Or there's just too much work involved in making it work for you, right? So there's a lady named Ellen Ullman, and this is one of my favorite quotes from her, is that she says, "We build our computers the way we build our cities, over time, without a plan, on top of ruins," right? And part of why I like this quote is because that has a lot to do with like, why is Kubernetes insecure by default? Where did Kubernetes come from? What's the history of it? Like, why did it end up with some of these concepts, right? Like, where did this come from? So here's, over time without a plan on top of ruins. Here's a CPU, right? And here's like a Mayan excavation. You know what I mean? Like it's all kind of similar. We're building stuff on top of ruins, on top of other people's work. And so I'm starting off with a couple quotes here because I like to just kind of describe like my position on some of these things, right? But this is Werner Vogel's AWS CTO. Who's running on AWS? Anybody? Yeah. Like this is the CTO of AWS saying everything is failing all the time, right? Like this starts to get into semantics, like or like systems thinking, right? Like you think your stuff is working, but it's actually not really most of the time. Most of the time things are failing. You just they're sort of working. You know what I mean? Same with Kubernetes, right? And then Mike Tyson, right? Everybody's got a plan until they get punched in the mouth, right? Like that's how this stuff works, right? Like everything's great until one of your applications gets hacked, and now you get punched in the mouth, right? Like what do you do after you got punched in the mouth, right? So why is Kubernetes insecure by default, right? There's actually a documentary on Kubernetes. If you want to watch it, I'm not going to make you watch it here. But who's familiar with the Borg, like the Google stuff so they put out this paper quite a few years ago now, like it's getting to be kind of old, right? But this is largely where Kubernetes came from. They wrote this paper. This is what they were doing internally. Here's a paper that describes all the stuff we were doing. Maybe we should take some of those ideas and like make them open source, and that's where Kubernetes came from, right? So this would be like kind of the history of Kubernetes. Google works on containers in like 2006, right? Docker comes out. I think Docker was before Kubernetes, right? Like that changed a lot of stuff, right? Like Docker came out, and it actually influenced Kubernetes quite a bit when you think about it, right? And I have some questions for you as well, maybe you know. But one of the 2 or 3 big things that I'm wondering about is like, why are you allowed to run a container as root in Kubernetes, right? Like, why can you do that? And if you can kind of see the screen here, right? Like if you run, all I'm doing here is running an Nginx pod, right? Using the image Nginx. And then I'm catting like the first process PID number 1, right? Like that's how containers work. What's the first process? The process is Nginx, but what's it running as? It's running as 0, which is root, right? So this, if you just by default, if you run this in a vanilla Kubernetes cluster, this stuff is running as root, which means if somebody breaks into this container, it effectively has access to the entire host and you can do anything you want, right? Why can you run as root by default? I don't know. It's a good question. Some of it may come from Docker, right? And this, like, I actually have questions myself. Like, why is this the case? It seems to come from Docker's original stance. Is it just because of ease of use? Is it because somebody was like, well, legacy applications are going to have problems if we don't let them run as root, right? Like, where did this come from, right? Like, I don't actually know. The second point that I have, so we talked about running as root, right? The second point that I have is the network is wide open, right? Like by default, if you just run a vanilla Kubernetes cluster, every pod can talk to every other pod on layer 3, right? Like this is the default stance. Like it might not be like that in your organization, but this is what it is. If you just like create your own vanilla Kubernetes cluster, every pod can talk to every other pod, right? And so this was actually a design decision from Google, right? Where they wanted everything to be able to talk to everything. Like in some ways, it was like a singular organization. They didn't have to worry a lot about like multi-tenancy and those kind of things, the things that we have to worry about. So when they started, they're like, let's just make everything wide open. We'll do it on layer 3, so it's like super scalable. We can run 1 million pods. It's all good, right? I mean, network policies were added pretty quickly in 1.3, but they didn't come there out of the gate, right? And sort of this point here, I mean, you can't read this, but basically what they're saying is like when we first released Kubernetes, everything was wide open. Some people don't want it to be like that. You want to be able to add some sort of network policy to limit, what pods can talk to what, right? But when you put those two things together, like the reality is that in a default Kubernetes, like the onus is put on the people using Kubernetes to add this security in, right? Like by default, you can run as root. By default, there's no network policies. Like you have to do the work, which I think is interesting because you have to do the work, right? Like what if you don't want to do the work? Then you just get root pods. You just get full network connectivity, right? So what can we do to make Kubernetes secure by default, right? So these are the things that I'm suggesting that anybody can do with their Kubernetes clusters, right? One is like add a secure baseline, don't allow root containers, and there's a bunch of other things that you could do that I'll show you too. And don't allow pods to talk to other pods in other namespaces, right? Like in Kubernetes, you can create a namespace. It's like kind of like a project group almost, right? You can think of it that way. But what if we set it so that just pods in that namespace could only talk to each other and go outbound, but not talk to other namespaces, right? Because why would they need to do that? And then once we've done those things, we probably want to automate it, right? Like let's make sure that that is done by default. So if you create a new namespace, let's make sure you can't run root containers in it. Let's make sure that you can't, that you have a network policy in it, and let's automate that. And then finally, the part where Sysdig and Falco come in is what happens when you get punched in the mouth, right? Like what happens when all of the security controls that you put in don't work, or they get bypassed, or somebody disables them, right? Like what happens then? And that's where Sysdig and Falco come in with like runtime threat detection, right? Like what's actually happening. So those are the three things that I'm suggesting everybody could do to make their Kubernetes secure by default, right? Is this mic still working? Yeah, okay. Who's familiar with the recent changes where they added pod security standards? Anybody? Yeah, so there's one or two. So before you used to have PSPs, so this PSP piece, right? Pod security policies used to have pod security policies. They got replaced with PSA, pod security admission, and pod security standards, right? So it doesn't really matter the details, but the point is that there's a new way to configure like some baseline security, right? And so what I've got up here is the command that would actually label the namespace so that it was enforcing restricted. And when you say enforce restricted, these are the things that it requires that a pod deployed in that namespace to have, right? So it's going to limit the type of volumes, don't run as root user, no privilege escalation, you know, et cetera, right? So if you set this, then you can't deploy a pod that has those things enabled, right? They have to be like specifically disabled. Yeah, and this is just another example of the, like, you have a few different choices that come by default, privileged, baseline, or restricted. And today I'm talking about the restricted one, right? Does that make sense? Everybody? Yeah, good. And then this is an example of a network policy. You probably can't read it all the way back there, but here's a network policy. And basically what it says is don't allow pods to talk to other pods in other namespaces. Do allow pods to talk to one another in the same namespace. You're still gonna have access to like Kubernetes services. Do allow egress outbound to the internet. Maybe your company doesn't want that, but this would still work in most environments, right? And then, and again, it's sort of meant to work kind of anywhere, right? But there's not like, so we have that information, but what's the point if it's not default? What's the point if it's not automated, right? Like if somebody creates a namespace, this stuff should all be added by default, right? So let's do that by default. One way to do that is to use a Kyverno cluster policy, and that's, again, you can't read this, but what we've got here is a cluster policy, and what this is going to do is when you create a namespace, it's going to make, when you create a pod, it's going to require that these values are enforced, right? Like all those things that I was talking about before about privilege escalation and all that kind of stuff, right? We're gonna require that those are there. And we'll do the same thing when we'll use the same kind of technology. So when we create a namespace, yeah, sorry, go ahead. Yeah.
Seems like it does similar things.
Yeah, basically like, so there's, the way to think about it, I think, is that like, for example, with admission controllers in Kubernetes, you can have a validating admission controller, right? Where it's just like, does this meet our policy? If not, then reject it. But you can also have an admission controller that mutates the workload, right? And mutate is like a cool, fun word to use in meetings where it just means it like automatically alters it for you. So what you're talking about, OPA, it doesn't mutate things. It doesn't change them. It just says, does this pass a policy or not? What I'm talking about here is we're going to alter, like when you create the namespace, we're going to enforce, we're going to mutate it, right? Change it so that it has enforced restricted on it already, right? And we're going to enforce, we're going to have it generate a network policy. So as soon as you create a namespace, it's automatically going to add that network policy, right? So OPA, I don't think can do that. I'm not aware that it, yeah. So that'd be the difference, right? We're going to mutate stuff, which is actually, I think, a big part of Kubernetes, right? Like we just use Kubernetes to create containers, but you can actually use it to like mutate stuff all over the place, like change everything. And I'll show you one of those kind of fun changes, right? But that's the difference, yeah. However, the part about this is if we force containers not to run as the root user, some images aren't configured to work that way. So you're going to have to make some changes to your actual container images, right? Because if you just run that Nginx image, it won't work, and that's what's here, right? So if you require it not to run as root, and you try to run that plain Nginx image, you're going to get an error. It's going to say container has run as root, run as non-root, and image will run as root, and it's just not going to work, right? So this could be like a breaking change where if you had images, and you shouldn't really have images that are running as root, but if you did, then they wouldn't start up, right? But we can also use that same mutating idea to change those if we want to, right? And this is a bit of a workaround, but like what I've got here is another sort of like policy that's going to make a change, and I'm going to change the Nginx image to Nginx unprivileged, which is a version of Nginx that doesn't run as root. But I'm going to do this like automagically behind the scenes, right? But so it's a bit of trickery because if you actually did this, you might have some images that wouldn't work, right? Okay, let me see if I can run the demo here. So if you can, I don't know if you can quite see that, but so what I'm going to do here is I'm in a Kubernetes cluster. It's got some network or namespaces. I guess you can't read it, but I'm going to create a namespace. Maybe if I move this up a bit, actually, hold on a sec. There, okay, how about that? Okay, so I created a namespace called Test Monday. And then the question now is, right, after all the stuff that I just told you, if I go to run Nginx, is this going to work? Right, like after all the things that I told you, I'm automating these pieces. Should I be able to run this? Right? Who thinks yes? Who thinks no? Anybody? No? Some no's? Yeah. Okay, so roll blend. I'm just going to run it. This container is going to create, I'm going to watch it create here for a couple of commands. I just did this today. So, and then I think at one point here, I forget what the like wait command is. And I'm like, -- wait. No, that's not it. But now it's running, right? And so if I look at the namespace and get the YAML for that namespace, we can see that it's got this enforced restricted, right? That was automatically added. Now I'm going to check and see if there's any network policies in the namespace. Even though I just created it, yes, there is, because because it's automatically added. We can see we've got this network policy already, right? And then I'm going to check the pod that I deployed, look at the YAML of that. And we can see that we've got a bunch of like security contexts. And I'll scroll up and show you some more of that one, not there. But let's scroll up here. So anyways, yeah, so one of the things I told you that one of the tricks that I did, right, is I changed, even though I said run this Nginx image, I had the cluster policy mutate it and change it to the Nginx unprivileged image behind the scenes, right? But that's basically it, right? Like we've done a couple things to create a secure baseline. It's automated, and now in theory, like you can't run containers as root here, but if you run the Nginx one, it'll like magically make it work, right? Okay, how much time do we have here? Real? Yeah. Okay. Set back to my slides. Also, I think we were talking about like maybe mentioning some things that are new in Kubernetes too. There's a validating admission policy system that's brand new. I won't get into this too much, but there's like a new language. Like, so you were talking about Rego and OPA. They also have this new idea of using a different expression language. I think it's called CEL or something like that, but they have a built-in model that does something similar to that, right? So in summary, enforcing restricted, we added network policies and then we automated all that, right? But now we need to talk about the last line of defense. And I might speed through some of this. I don't want to take up too much time here. But so we did all that baseline work, but now what happens if somebody breaks through all that stuff and you get punched in the mouth, right? I think the interesting thing about security is that it's adversarial, which means that there's people out there that are actually trying to break into your clusters, break into your stuff, right? Like that doesn't really happen in other jobs. I mean, I guess if you're working at a convenience store, maybe somebody might try to rob you, but like security is a weird industry because people are trying to break your stuff, like real honest people, right? They're out there trying to break your stuff. Just like MGM got broken into, right? The other interesting thing I think about a lot of the work we do in security is that we focus so much on vulnerabilities, but this is a paper that talks about how, you know, the average age of a vulnerability in the code before they discover it is 4 years, right? So even when you get a vulnerability that's fixed, right, you get an updated package, you deploy it, that vulnerability has probably been in the code for 4 years, and somebody could have been exploiting it for that amount of time, right? Which, you know, is interesting. And some software projects have longer periods where it's like 7 years and some have shorter, but it's not zero, right? I think I'll skip over a little bit of this. But a big part of what we do with containers, I think, is that we're kind of filtering them, right? So containers don't really contain, they're not a virtual machine. What they're really doing is they're filtering all the different system calls that are coming through, right? Like we're filtered, like in order for an application to work, it's got to talk to the kernel. And in order to talk to the kernel, it does system calls, right? Like no matter what application you have, whether it's Java or Go or whatever, it's got to make system calls, right? And so what most of these container runtime systems are doing is they're filtering those system calls to try to make your systems more secure for you, right? It's not perfect because filtering is hard, but that's what they're doing, right? And so we have these tools inside these runtimes like seccomp and AppArmor and Linux capabilities and all this other stuff. But the point of what they're really doing is filtering these system calls. They're going to try to allow the good ones through and stop the bad ones from happening, right? But this is where Falco comes in. Has anybody heard of Falco before? It's an open source project, part of the CNCF. One person has heard of Falco. So what Falco does, and I'll show you a bit more about this. So again, open source project, Sysdig supports this project. It's used by lots of different companies around the world, part of the CNCF. I think it's going to graduate, like this, the CNCF Cloud Native Computing Foundation has different like levels. We're like sandbox and graduated, so it's about to graduate. There's only a couple graduated projects like Kubernetes and what's another one? I can't remember, but there's only a few graduated projects. But what Falco does is it sits right in the kernel. So when you deploy Falco into a Kubernetes cluster, what it does is it deploys either a kernel module or an eBPF probe, and then it sits there and it sees all of the system calls, right? And then what we can do with those system calls is apply rules to them. So we can say, and you can't read this, but it's basically like, if this happens and this happens, then something's wrong and fire an event, right? So this is your last line of defense where you've got an application, say somebody pops an application, downloads a malicious binary, tries to run it. That binary has got to make system calls, right? Falco is going to see those system calls. We're going to apply rules to it. And if those rules, if what it's doing violates those rules, then you're going to get an event, right? But this is the last line of defense, right? Like somebody has gotten through all of your controls. Now, what do you do? Now, how do you know that that's happened, right? This is how you know with something like Falco or Sysdig Secure, right? But it's also it's deterministic. It's like, if this happens and this happens, then fire an event. If that issue happens again and it happens, you're going to get another event, right? Like it's deterministic. It's not based on like machine learning. It's not chat GPT where maybe it happened, maybe it didn't happen. It's rules based, right? And I can do a little quick demo too here of that. Okay, and this one is basically where like you're not really supposed to get a terminal shell in a container, right? You're not supposed to log into a container because why are you logging into a container? Like there's no reason for anybody to be logging into a container. So like the canonical sysdig demo is to like show somebody logging into a container and then you get an event, right? So what has happened here is this is all happening in Kubernetes. I checked the logs and then I ran, and I'll just scroll up a little bit here. I checked the logs, right? So there's nothing in the logs here. And then I logged into a container, getting a terminal shell in a container, right? So I logged into a container, I said, hi there. And then I'm checking the Falco logs again. And it might be hard to read this, but this is basically an event, right? Like the rule terminal shell and container was violated. You're not supposed to be able to log into a terminal shell. And you get an event where it says, notice, a shell was spawned in a container with an attached terminal, right? And so it looks really simple, but it's kind of an important thing to have happen, right? Is like somebody got through all of your controls, they were able to do something they weren't supposed to do. Now you get an event, you get a log, and you can send that anywhere you want to, right? Like that could go into your SIM, that could go into a Slack channel or whatever you want to do, right? But you're going to know that something happened. It's that last line of defense, right? Any questions about that? Yeah, sorry, go ahead. Right
there. Does that tie in directly to Alert Manager, or would I have to be creating an alert for that log?
Yeah, you would. So basically, like Falco is an open source project. It doesn't do like a lot of the enterprisey things because it's just an open source. It's like Kubernetes, right? Like nobody's going to use, typically people don't deploy Kubernetes on their own. They're going to use somebody's distribution. Same idea, yeah. So Falco can generate this alert. There's a couple of projects that will allow you to send that alert somewhere. But yeah, you would need to do a little bit of work if you wanted that specifically to generate something, yeah. Sorry, you had a question, yeah?
Thanks. Is it only alerts? It can't actually like stop it, like forbid this action or something?
Yeah, that's a great question. No, it can't. Yeah, it doesn't. It just sends you an alert, right? Yeah, yeah. And so anyways, like this is part of a larger talk, but like what we're talking about is I've mentioned system calls a million times, right? But we're sitting in each of these Kubernetes nodes. We see all the system calls, and that's a pretty awesome place to live from a security perspective because we see everything, right? And again, I'm just emphasizing the point here. So you've got all these controls, you're filtering everything, but something still made it through. And then we've got Falco that's there for the last line of defense to say, hey, something made it through all your filtering, but you got to do something about it, right? Also, Falco doesn't just look at system calls. We can look at audit logs, any kind of streaming log file. So I mentioned Mgm already, right? That recent event with Mgm where they had an unplanned encryption event. But one of the ways that people are suggesting that happened was through Okta, right? Like somebody was able to social engineer, get in through their Okta, and then somehow encrypt all of their ESXi tools. I'm not 100% sure about all this, but this is what people are suggesting, right? But we can also look at Okta logs as well, right? Like any streaming log file. So in potential, you could point Falco at a streaming log file. There's plugins that you can use, so it's not just system calls, right? Like what are the system calls in the cloud? There's no system calls, but there are audit logs, right? Okay, so Falco again, last line of defense. If something does go wrong at your business, somebody's going to ask you to like tell a story about what happened, right? Like, did our Postgres database get hacked? You know, like somebody's going to ask you to tell a story, and these are the things that Falco can help you do. It's very easy to install. If anybody wants to install it, come talk to me. There's only 3 commands you need to do. It's just Helm based. But to ask or answer more about your question about can you do something about this event, that's where Sysdig Secure comes in. So we add those kind of capabilities on. So Sysdig Secure can kill a container or stop a container or pause a container when one of those rules is violated, but that's part of the commercial system, right? So Falco is an amazing open source project, but it kind of does one thing really well. If you need to do more than that, then that's where the rest of our platform comes in, right? But that's it. So that was a really whirlwind tour, I think. But does anybody have any questions about what I talked about? Yeah.
But how does the actually manage the vulnerability? So like when the system call has already made to stack on, then does it actually keep the filter to actually trigger how to be notified that something has occurred?
Yeah, exactly. So if I go back to, let's see, this slide, right? So part of Falco is sitting right in the kernel. So it's going to see any system calls, and basically it has a rules engine that executes this rule, right? So it's watching system calls, and if it sees this kind of system call and this kind of system call, then fire an event. But yeah, it's sitting right in the kernel. It can see everything.
But if it's actually seeing system calls, then how does it actually know if Kubernetes events? So Kubernetes events, I would assume those are high level than system calls.
Oh.
Going through the kernel and eventually getting the EPF filter, then those actually get much lower level and
Right.
it's like lower level.
Yeah, Falco can talk to the Kubernetes API. Yeah.
So it's actually like sitting both in user space and
Exactly. Yeah, exactly. Yeah, yeah. Yeah. Sorry? Potentially, but you'd have to be root, right? Like, and if something's root and something, then they're already root. So you're in trouble already, right? Yeah. Yeah.
This performance penalty for random call.
Yep. Yeah. So like it's in the kernel, it's doing work, but Sysdig has been doing this for like 10 years. So they've seen everything. Like Falco has seen everything. We're really good at tuning this stuff. I think it can be anywhere from like 1 to 5% of a single core. Yeah. It's pretty low. But it's doing work, right? And also like the busier the server, the busier Falco is. If your Kubernetes nodes aren't doing anything, then Falco's not doing anything either, right? Yeah. 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 It does do work there, yeah.
When you mentioned the log streaming part, so does it come pre-configured with certain things? Because log services, they're so varied in terms of how they're structured and stuff. So does it come pre-configured in terms of what to look for in like a log file of various services?
Yeah, for Falco, there's a plugin model. So you would deploy like the Okta plugin, and that would, I haven't looked myself actually, but it should come with some rules, like some default rules. Sysdig Secure is going to come with a lot more rules, obviously, but yeah, that's the idea. Like there's a plugin, there's some rules, but yeah, you'd have to have some rules that are matched up for that particular log file, yeah.
Hey, so thank you, Curtis. I think I learned a lot. Like it's a lot of takeaway for us. First of all, thank you, Curtis, for
Yeah, thanks. And if you disagree with anything, let me know. Happy to talk. Yeah.
And our next topic is Istio service mesh. Simon is from the Solo.io, and he's been here as a field engineer and been in I think 20 years experience in
25 years.
25 years, yes. Application networking, enterprise customer applications. So what do you?
Hey, thanks a lot. Nice to meet everyone. My name's Simon Green, and I'm a field engineer here at Solo. And for those of you that haven't heard of Solo, we basically support enterprise. We provide enterprise support for the Istio project. And yeah, I've been in the app dev world for roughly 25 years. I'm not an infra guy, so I kind of approach it from a developer's perspective. And we're in the business of what we call application networking. So we look at networking through the lens of applications as opposed to infrastructure. Now, I typically help customers who are reasonably new to kind of application modernization. They might have just started containers, they start using Kubernetes, but they tend to be struggling with networking, especially in the realm of Kubernetes, because it's very, very different to, say, traditional networking. Next slide. What I like to do is, okay, well, first off, I just want to ask one question. Has anyone heard of Istio before? Have any of you Yep. Okay. It's a few people there. And are any of you actively using Istio at the moment in your organization? No one? Well, not yet, maybe. Okay, perfect. So what I'd like to do is just talk about where we came from and give you a bit of a history lesson on traditional networking. So what we have here is two different axes. We've got north-south, which is traffic that originates usually from externally out of the network, and you're getting traffic into your network. And then on the bottom, we have the east-west axis, which is really traffic that's going kind of from left to right or backwards and forwards. So the way that we've traditionally dealt with this, getting traffic into your network, was using things like firewalls to kind of provide things like authorization and secure network traffic. And then we used things like load balancers to help with, say, routing of traffic, so getting it to a particular application, maybe doing some traffic management and naming, so things like DNS naming, that kind of thing. Then at the bottom, you've got maybe a front-end application that we might be routing traffic to, which might be front-ending, say, an API service, and that service might be talking through another firewall to, say, a database. That's all part of, maybe your trusted zone. You usually delineate networks with maybe a DMZ, inner and outer DMZ, and then a trusted zone. And once it's in the trusted zone, you typically, trust all the traffic within that particular zone. Now that worked great when everything was kind of static. We weren't creating new replicas of applications. You might raise a ticket with an administrator to update a firewall rule or a load balancer. But what ends up happening is, if we go to the next slide, we introduce, say, maybe something, a containerization orchestrator like Kubernetes, where now everything is more dynamic. We have to deal with maybe new replicas of applications spinning up. And one way of kind of taking the load off our traditional infrastructure like firewalls and load balancers is to add what we call an API gateway. And an API gateway is kind of a centralized gateway, really not that new. You could probably, I guess we had some form of API gateway in the form of mainframes once upon a time, but API gateways are useful because you can actually take some of the load off the firewall and the load balancer, start doing things like ingress and routing rules, which are a little bit more dynamic, helping with security, so maybe authenticating with Okta or OIDC, and then doing things like rate limiting, so preventing clients, external clients or internal clients even, from overwhelming a particular service. So this is kind of like, I suppose, the first step towards, cloud native networking. So when we talk about microservices and Kubernetes, I kind of like to look at it through the lens of a crawl, walk, run philosophy. So in this case, in this particular example, we've got two different applications. Application A on the left wants to talk to application B. And traditionally what would happen is they'd have to go and kind of hairpin back through a firewall and then go through a load balancer to be routed to application B using some kind of IP. Now, that is quite static. What we could do is add something called service registry or service discovery, we call it. And this is just, a simple application that holds a registry that can be queried by any application using either DNS or maybe HTTP. And what you can see is application A is querying this registry, and what it gets back is some kind of address. In this case, it's, application b.service.mesh, and that address will map to some kind of IP. Now, this is still manual in that firewall rules and load balancers are still part of the network flow, and they still need to be updated manually. So the next phase would be the walk phase, and no worries. So the walk phase, here we still have the application of a service registry, but we're going to introduce, say, more of a pub sub flow, in that whenever application B adds a new version of its service or a new replica, it has to publish that change to the service registry, and service A, in this case, the load balancer can subscribe to those changes. So any routing changes actually get pushed out to the load balancer. And now we have more of a dynamic flow of updating our load balancer or potentially firewall rule with any changes to this. So this is, on top of the service registry, we've kind of added more of a pub sub flow to our networking flow. And then the last phase is the run phase. So this is where we eliminate the firewall rule and load balancer from the equation. What we've done is actually added the proxies and embedded them into the application themselves. And this is what we call the sidecar pattern. I don't know if any of you have heard of this, but the proxy is now part of the application. We've pushed the networking concern out to the edge. And now we've also got, we can include an encrypted channel between services. In this case, we're using MTLS, and we can assume that all networking traffic is adversarial. So we don't trust any kind of service or actor within our network now. And this is what we call zero trust. So this is a really, really important philosophy with cloud native networking or application networking. So we have MTLS for both identity and also an encrypted channel between our applications. We've eliminated the static networking infrastructure that we had with the load balancer and firewall, and we're able to do things like authorization using network policy and application networking policy. So just to summarize how we do microservices networking, so we pushed the networking concerns because we're in a more of a dynamic environment now. We push those networking concerns to the edge using sidecars or sidecar proxies, and those proxies are now co-located with our applications. So in the context of Kubernetes, we would have a separate pod that's associated with that workload. And we do still have a place for the firewall and load balancer. We can still use those traditional appliances for ingress into our Kubernetes clusters and still do things like routing and naming and traffic management. But for east-west traffic on I guess it's the x-axis, we're going to use our service mesh. So service-to-service communication, cross-cluster or cross-cloud, or even within the same Kubernetes cluster, we can use this sidecar model that I just talked about. So just to level set on what Istio is, and I know most of you are quite familiar with this. Istio by default, it's one of the, I guess, most mature service mesh community projects. It is a fully graduated CNCF project now, but its default deployment model is what we call the sidecar model, which I was just talking about. And here, in this case, we've got those two services, service A and service B. And if they want to communicate with one another, they communicate via a sidecar proxy. So that's really the default way of doing this. And those sidecar proxies, that forms part of the data plane. And then they have a control plane called Istio. That's kind of like the orchestrator, and that's where any kind of new network policy or configuration, or maybe new certificates for the sidecar proxies, they all get pushed out from the Istio control plane. So as default, that's what we have with Istio. So this is what it looks like. In this case, we've got 3 Kubernetes clusters, and each app has its own Envoy proxy. So Envoy is the default proxy that Istio uses under the covers. And in this case, the Istio control plane is only deployed to node 2, but any changes, any network policy that we want to push out to say, I don't know, circuit breaking, or, to push out authorization policies, which apps can talk to one another, or any kind of routing, they all stem from the Istio control plane on node 2. So Istio, it's been around since, 6 years now, 2017, and it's evolved. It's now a fully graduated CNCF project. But recently, Google and the company I work for, Solo, well, not recently, for the last 2 years, we've been working on a new project. Well, it's not a new project, but it's a new deployment mode of Istio called Ambient Mesh. And this came about from feedback from the community and adopters, Istio adopters, that, we love the sidecar proxy model, but there is a pretty big disadvantage. And that is the fact that for every pod, every workload that you have in Kubernetes, you're going to have another Envoy proxy. So in some cases, with some adopters, it accounted for roughly 30% of cloud cost just to run Istio, which is incredibly high. So the feedback was, let's do something. Let's find an alternative deployment model for Istio that doesn't require sidecars, and what we call that is ambient, which is part of the Istio project. So the goal of Istio is of ambient mesh is to reduce costs, so workload cost, so that you don't have to spin up all of those sidecars. Help simplify operations by reducing the number of certificates that need to get rotated, or the observability concerns that you have with sidecars, and also to improve performance as well. Improve the performance of the overall mesh. So just to kind of compare and contrast, on the left-hand side, you have the sidecar model, where every single Kubernetes pod that is part of your service mesh has an associated sidecar. And then in the middle, you have the equivalent ambient mesh deployment. So instead of having a sidecar per pod, we now have one proxy per Kubernetes node. So that dramatically decreased the number of proxies you need. And we've actually rewritten the proxy. It's no longer Envoy. It's actually written in Rust, and we've called it the Z tunnel, which stands for Zero Trust Tunnel. Or so it's the Z tunnel proxy. And we've actually split out the concerns as well. So layer 4, all the layer 4 kind of policy concerns and things like MTLS and workload identity, they all happen within the Z tunnel. And as an option, you can add another proxy called the waypoint proxy for application level policy. So things like circuit breaking, or I guess the API gateway type concerns like rate limiting, anything like that, you can optionally deploy a waypoint proxy per namespace. So think, if you hear ambient mesh ever brought up, just think of it as an alternative deployment model for Istio. So what that ends up looking like is you've got the layer 4 proxy, which kind of just is on top of the CNI layer. It's going to handle traffic between nodes, and then the waypoint proxy is that layer 7 proxy that I just mentioned. So if you're interested in learning a little bit more about this, at Solo, we have a really cool website called Solo Academy, and it's very much community first. So we have certifications around Istio, ambient mesh, around Cilium, but we also have some other certifications using our products as well. And any of you are free to sign up, and yeah, you can get Istio certified if you want to, and put it on your resume or on LinkedIn or something like that. So yeah, if you're interested in learning more about Istio or the company I work for, solo.io, here are our website, and yeah, just go to solo.io and look for Solo Academy if you're interested in the certifications and maybe doing some hands-on labs, or feel free to come and talk to me while we're enjoying pizza as well. Perfect. So any questions that anyone had about what I just covered? Oh, no, go ahead.
Different sources. So does it stay? Is that on the server, on the Istio D controller?
Yeah, so the Istio D kind of acts as that service registry. So anytime a new service gets added to the mesh, it gets published to the Istio D, and then the Istio D pushes that out to all the data planes that are as part of that mesh. And that's controllable, it's configurable, because maybe you don't want all the data planes to know about that, all the sidecars to know about that. Also, there's significant network costs associated with doing that, but that's generally the flow. So Istio D acts as that service registry.
Yeah, thanks.
Yeah, really good question.
Thanks for the presentation. Can you talk more about pros, cons, running Istio versus running without it? Like, what's really like, why would you want to run it?
Yeah, so the question was, what are the pros and cons of sidecars versus sidecarless? So some of the disadvantages of a sidecar is, of course, the workload cost, the fact that you've got, a sidecar for every single pod. Another disadvantage is having to rotate all the certificates for that. There's the day two ops. Istio lifecycle management has historically been a real challenge, especially with like root trust policies and managing CA certs and that kind of thing. That's been a big challenge. The other thing is there's race conditions. So with folks that have applications that use things like init containers, there can be an example where maybe the application actually starts before the sidecar has started, and then there's some kind of race condition where the application is unable to communicate with the other services, and it kind of gets into this loop, which it can't resolve from. So it's those kind of situations that, that was feedback from the community is we need to fix that. With the ambient mesh, with the sidecarless, it's going to help with those problems because now you're only going to have one proxy to update. So with the lifecycle management, it's one proxy per node, which is really helpful, not one proxy per pod. So with certificate rotation, and then of course the workload costs, the fact that you no longer have to allocate CPU and memory for every single pod, every single sidecar. So you don't need to do that with ambient. With ambient, you're only going to just assign enough CPU and workload and memory just for that particular Z-tunnel proxy, and you're only going to add the waypoint proxy if you need it, because most service mesh adopters, they just start with MTLS and workload identity, and then like in the future, as the run phase, they might add the application policies for canary deployments and all that kind of stuff later in their deployment, in their adoption. So it's those kind of things.
About like the general, why would you want to run Istio?
Oh, Istio in general. Yeah, so in general, it's community backing. So the fact that it is multi-vendor, we have IBM, Red Hat, Google, Solo, Aviatrix. There's so many companies and individuals that are contributing to the Istio service mesh. As opposed to other service meshes that I've worked with. I've worked with Kuma, for instance. Kuma is also open source, but doesn't have the community backing. And a lot of the folks that I worked with on Kuma, they could never get into production. That was always a struggle. So it ends up being more of a toy as opposed to actually getting it into production. I'm now helping customers with Istio who are managing thousands of Kubernetes nodes all running Istio, as opposed to just playing around with it as a toy. So yeah, so stuff like that. Yeah, really good question. Thanks.
Thank you. Hi. So we use Linkerd.
Yep.
So we were evaluating Istio as well. So back then we had an issue with observability, building the observability. It was like 3 years back. I'm not sure if is there any observability built into Istio right now?
Yeah, so that's actually something. It depends on what you mean by observability. What we at Solo have done is we've built an observability platform through having a dashboard, for instance, that's based on a production readiness checklist that I helped build. And also things like open telemetry, we've added things like that. And I believe that's also part of the community. We've contributed a lot of this back to the community. Another thing that we've heard with Istio is it's complex to manage. A lot of folks, like me, as a developer, it's kind of difficult to upgrade. It's difficult to configure. So I think it's got a lot better. And that's something that I enjoy doing at Solo is kind of help making it better because we've got such a strong community. Yeah.
So we had a couple of use cases. One is like using Istio with Argo.
Sorry, using Istio with
Argo CD.
Oh, with Argo, yep.
Yeah. So we were not able to load balance gRPC calls.
Okay.
Right. So is there any? That was one of the drawback which we were noticed back then, but I'm not.
Yeah.
sure if it is.
I'm not sure about gRPC, but I know that there's constraints with, say, Envoy proxy that can't handle, for instance, it can't handle UDP, for instance. So if you've got an application like a kind of a, a trading app that needs, low latency kind of metrics to run and needs to run on UDP, then that's not a good use case for, say, Istio because of Envoy. Envoy doesn't support UDP. Well, and it still doesn't, to my knowledge.
Okay.
So it really depends. I don't know if Linkerd is able to do stuff like that, but it sounds like it probably could. Yeah.
It does.
So it just depends on your use case and what kind of application you want to run on top of your service mesh. But it's a generic pattern. Service mesh is a generic pattern. It just, depends on which community project you want to back.
Did the drawback get resolved with Z-tunnel?
So what was that? The
Drawback with the low latency ERP based.
Oh, so that's actually interesting. With the Z tunnel, you don't have that constraint because it's no longer using Envoy. So that's actually thank you for answering my question. Yeah, Ambient is actually solving problems like that for us as well because it's running Rust and it can actually possibly fix your gRPC problem and definitely the UDP problem as well. Yeah. It's just written differently. It's not Envoy is written in Go, I believe, and had some issues running on Windows and things like that. And then with Z-tunnel, because it's in Rust, it can be compiled into all kinds of different languages and have better protocol support. That's what I've read. There's actually I don't know. There's a community blog about why they went down that path, and it's really detailed. So I can definitely share that with you. Yeah.
I have a question. I also wanted to add, I think from my experience, some of the things that I've seen that are beneficial with service mesh is like fine-grained access control rules. And I think also with removing like a centralized point of failure when you're using like a central registry. And then my question is, how does Istio scale when especially with the sidecar model? And having some small sets of control of Istio D servers pushing or pulling information to ensure consistency. So there's potentially some risk as access rules change. Maybe if you have a lot of servers with that kind of latency. So how does Istio scale with like large workloads?
Yeah, that's a really good question. So Istio traditionally is built for single cluster. It's really just one single Kubernetes cluster. There are community modules to allow you to do multi-cluster and to be able to push network policy across multiple Kubernetes clusters. But what ends up happening is you get what we call config sprawl, in that you have to maintain the configuration for every single individual cluster that you've pushed configuration out to. So at Solo, what we've done is we've created an abstraction layer on top of the Istio CRDs that allow you to push out configuration to multiple clusters using an agent-based technology, and that converts from like the Solo CRs to the native Istio CRs and kind of resolves that way. So that's the way that we solve that, and it's kind of a common problem, that we've seen.
Thank you.
Yeah.
Any more questions? Okay, I think we are good. No questions, right? Okay, but if you have any further questions, then reach out to Simon or or K8SUG Canada. You can email us. Thank you so much, Simon, for this.
Hey, thanks everyone.
So just 2 minutes between you guys and Pizza. So basically, we got talked to the Packet Publications, which is basically book sponsorship. Like they publish the books. So we are talking to them, and they are ready to give us some books for the people. So today we don't have any quizzes or anything. So what I'm gonna do is I'm gonna scroll down the Meetup page. Whoever comes first, I'm gonna call the name. If the person is there, I'll get a book. So I'll share the book name first. So first is Mastering Elastic Kubernetes Service on AWS. The other one is the Ultimate Docker Container Book. So First name is Donna, if Donna is here. No? Okay. Again. Arun? Okay. So which one you prefer? AWS versus Docker? So first is EKS on AWS. The other one is the Docker container book, the mastering Docker container. Okay. That's cool. Cool. Thank you. Is there Mike? No? Maria? Okay. So you get the AWS one. Thank you, guys. And our next meetup is on 19th October. It's a Thursday. We realize that Monday might not be successful again. So, yeah. Sure. Me, bye, Victor. Okay. Sorry. Take one.
Take
Thank you.
that for you later on.
Yeah, we will try to get more books again from Packet or whoever planned to give. So like 1 minute common mic, if someone want to announce something, either they have an opportunity in their own organization or something, if they want to speak up. So these are recorded as a Zoom videos. If you want slide, you can message me on the event chat. I'll get you them. I hope it's okay with you guys to share, right? Okay. Thank you, guys. We have pizza outside. We have some drinks. I hope you guys like that. Thank you very much.
Oh, yeah, sure. For the go ahead. Okay, sure. Ashwin. Mission. Sure. We didn't say that. Okay. Was one minute. What I confused. Yeah, good chance. Okay, sure. Okay, got it. Okay, thank you so much. Sure. Let's meet now. Yeah, and maybe with the speakers. Oh, yeah, sure. Oh, yeah, we can take a peek. Here, okay. One more. Please, you guys have to come. These as well. Yeah, please. Okay. Can you give one teachers around? Yeah. Oh, we need this one actually. Yeah. No, we need the. Okay. Right now, I was seeing. So, thank you. Thank you so much. Happy food, guys. Yeah, so we are task force. Okay, so I think that was. This number.